Here we're going to do some examples of how to express planes and equations and sketch them and things like that. So let's start with example 1. Sketch the following planes for the Cartesian equations in R3 or 3D space. First one, 2x minus 3y minus 4z equals 6. So in order to sketch a plane, probably the easiest way to do it is just to find, as we discussed in class, the x, y, and z intercepts, right? So looking at this first equation here, if we think about what the x-intercept is going to be, that's going to be where y and z are both equal to 0. And then what's going to be the x value? So it's basically 2x equals 6. And then we can divide by 2, so x is going to equal 3. If we do the same thing, if we want to find what the y-intercept is going to be, that would be where x and z are equal to 0. Right? So if we do that, we're going to do 6 divided by negative 3, so y will equal negative 2. And we could do the same thing for z, basically set x and y to 0 and solve for z. It's going to be 6 divided by negative 4, which is negative 1.5. Okay, so we have our 3 intercepts, and if we have our 3 intercepts, we can plot. Just to make it a little bit more visible, I'm going to treat every line on this graph as every 2 lines on this graph as 1 unit. So in the x direction, I'm going to come out 1, 2, and 3. So I'm going to come all the way out to here for my x-intercept. Then for my y-intercept, negative 2, so I'm going to count 4 spots, 1, 2, 3, 4. And that will be negative 2. And then for my z-intercept, it's going to go down negative 1.5, so that's going to be right here, negative 1.5. Okay, so we have our 3 points, so now we can sketch our plane. Just basically connect those 3. And we have a plane. We see the plane's going to be below the xy plane. It's going to be below, and it sort of goes down to the z-axis. So that's it. That's all there is to it. Second question. Maybe a little bit more challenging here. How do we plot this one? Well, we can try the same thing. Let's find the x, the y, and the z-intercepts, right? Well, first of all, x-intercept, there's no x in the equation. What does that mean? Well, if we think about it like we did in class, essentially what this means is that it's going to be parallel to the x-axis, right? So the line is going to be parallel, the plane is going to be parallel to x-axis, right? So that's going to happen. We can still find the y and the z-intercepts though. If we set z to 0, we can find that the y-intercept is just going to be 0, right? Because that second part disappears. And if we want to find the z-intercept, we set y to 0. So then the y will go away and z equals 0. So essentially we know that 0, 0 on the on the yz plane is going to be on the graph. We also know it's going to be parallel to the x-axis. So that means it's going to run sort of in this direction here. But the question is, does it go up, does it go down, sort of what direction does it go? I'm actually going to erase those arrows there. So one way to do it, if you're stuck and you don't really know how to find another thing, let's find another point on this line. Specifically, a point on the zy plane, because we know that's where the plane's going to go. So let's say I just plug in, I don't know, a y value of 6. So I'm sort of just going to make like a little t-chart here, right? If the y value and z value, if the y value is 6, what's the z value going to be? Well, if we plug it into our equation, we're going to have 6, so just off to the side here, 6 plus 2z equals 0, and z is going to be, I think it's going to be negative 3. Bring it over there. Yes, negative 3. Okay. So I chose 6 because I knew it was going to have to be divided by 2, and 6 is divisible by 2. But anyways, So that's going to be a point on the YZ plane, right? So basically we can plot that point. So picture the YZ plane as like a flat plane, like the surface of your paper there. And if we go 6 over, 1, 2, 3, 4, 5, 6, if we go over here and then we go down 3 from that point in the Z direction, we're going to end up something like that, right? Somewhere down there. So just to sort of show you, I came across and down to that point there. And we know those 2 points are going to be on the line, and because it runs parallel to the x-axis, I can sort of just join those lines there. And because I know it's parallel to the x-axis, I can complete that plane sort of like that, because I know it's going to run parallel to the x-axis, so it's going to run like that, and that line is going to be sort of a constant slope throughout. So essentially your plane looks something like that. So it's like a plane that starts at the x-axis and goes down and to the right. You could obviously continue it up and to the left as well, but that's not necessary. And then we have this one, y equals -4, the simplest equation of them all, but what does that actually mean? Well, again, y is the only thing here. It doesn't have x, and it doesn't have z. If you remember what that means, it means it's actually parallel to the x and z axes, or parallel to the xz plane, and it has a y-intercept of -4. So we can easily plot that y-intercept of -4 right there. And it's going to be parallel to the xz plane. So the xz plane is the plane that comes straight out, the vertical plane that comes straight out of the board, or of your paper. And if it crosses through that point, one way to sketch it is sort of like this. So think of that line as coming sort of straight out at you, and it has a value of -4, right? So think of it as just like it's the xz plane that's been pushed to the left by 4, right? So it's that vertical plane like that. So the next question has us come up with the Cartesian equation. And the Cartesian equation, recall, is just ax plus by plus cz plus d equals 0. Now look at what we're given in the question. What is this thing? It is the equation, it is the direction vector of the normal. And if you remember, the normal is just the a, b, and c values in our equation. So let's start by just plugging that in. So we know a is going to be 2. 2x. B is going to be 3 plus 3y. And c is going to be -1. So -z plus d, we still don't know what d is, equals 0. Now we know this. How could we complete this equation by finding d? Well, let's look at the other piece of information in the question, the point. So if we know the point, we can obviously just plug that in to find d. So 2 times 1 plus 3 times -3 minus 5 plus d equals 0. Okay, solve that for d, and then you can unpause the video. There's your answer. D is equal to 12, so our equation is 2x plus 3y minus z plus 12 equals 0. So in this question, we're asked to determine the Cartesian equation based on 3 points. So I like to think about this just by drawing a quick sketch. Let's pretend we're just looking flat down on the plane like this, and we're gonna have 3 points like this that lie on the plane, A, B, and C. So how can we define the plane using these 3 points? Well, we need the Cartesian equation, right? And the Cartesian equation sort of looks like this. Ax plus by plus cz plus d equals 0. So we need to find what a, b, and c are. Now, notice, a, b, and c are not the same thing as the a, b, and c of the 3 points. Those are just the names of the points as opposed to the coefficients. So you could think of this in a few ways. One way to think about this is, can't I just plug in one of the points into that equation? Well, 1, 2, 5 is the first point, right? So if I plug that in, I'm going to get a times 1 plus b times 2 plus c times 5 plus d equals 0. Can I solve for any of those variables? The answer is no. You need more equations because you have 4 unknowns in this, right? So I could do the same thing with the second equation. A times, or the second point, I should say. What is the point? 3, 2, 4. So A times 3 plus B times 2 plus C times 4 plus D equals 0. I could try plugging one of these equations to the other. I can try making a third equation with the third point. Now, this idea, it's a bit crazy. There's a lot of algebra involved. There are some methods to do this, and we're going to learn some later in the course. But essentially, this way is not the most efficient way to do this, because we end up with a bunch of equations, a bunch of unknowns, and the algebra becomes very difficult. So we're not going to actually approach it that way. But what do you know about the Cartesian equation? What does A, B, and C actually stand for? What's something that represents that? And the idea is that A, B, and C is a normal to the line, right? A perpendicular vector to the line. So how can we find a perpendicular vector? Well, one way we can do it is we can actually look at AC as a vector and AB as a vector. If we do that, can we find a perpendicular vector to those two vectors? And the answer should be yes, we can, using the ever useful cross product, right? That's going to determine a vector perpendicular to AB and AC. So essentially that's what we're going to do. We're going to make two vectors, AB and AC, and then use cross product to define a perpendicular vector, and then just plug that into our equation, and then use a point to solve for D. So, first of all, AB, can we come up with the vector AB? Remember, A and B are just points, so we need to actually write the vector AB. Just looking at my points there, zooming out a little bit. So A, B, the difference between that, the way we find the direction vector is we subtract the points. So the x-coordinate is going to be 3 minus 1, which is 2, 2 minus 2, which is 0, and 4 minus 5, which is negative 1. So that's our AB. And then we could find our AC by doing the same thing. So subtracting, what is it? 1 minus negative 2, so that's like 1 plus 2, which is 3. Oh, sorry, I went the wrong way. I got to do C minus A, right? So negative 2 minus 1 should be negative 3. And then negative 3 minus 2 is negative 5. And then negative 6 minus 5 is negative 11. It should be a negative 11. So we have our two vectors, AB and AC. You could have done this, by the way, with any three of the vectors that are here. So let's now find AB cross AC to find that normal. And we can do that in the same way that we're used to doing that. So I'm just going to quickly write out this 2, 0, negative 1, 2, 0, negative 3, negative 5, negative 11, negative 3, negative 5. Don't need those, so I'm going to do 0 and then minus 5, negative 5, so 0 minus 5. And then negative 1 times negative 3, which is 3, minus negative 22. And then negative 10 minus 0. And that gives us cross product of negative 5, negative 3 plus 22, which is 28, and then negative 10. So there's our normal vector, right? This is a vector that's perpendicular to AB and AC. And because AB and AC are both on the plane, this is also perpendicular to the plane. So if that's the case, we can just use this as our A, B, and C values, right, in our equation. So I'm going to write that over here. So A is going to be negative 5x plus 28y. Oops, that should be 28y minus 10z plus d equals 0. So we don't know what d is. But if we look, we know a bunch of points on the line, or on the plane. We know 3 of the points. So in order to solve for D, we can just plug in any of those points. I'm just going to plug in A because the numbers are pretty small for that one. So negative 5 times 1 plus 28 times 2 minus 10 times 5 plus D equals 0. Okay, you can pause it here and find out what D is in your final equation. So D ends up being negative 1, and that's our final equation there. So how are we going to approach this problem? We have 2 planes, and we want to know the angle between them. Well, let's think about it. I'm just going to pretend we're looking sort of down the side of both of these planes. So they're going to intersect at some angle theta, right? One thing to think about is what we're given in the question, what type of equation we're given. These are both Cartesian equations of planes, correct? So if we're given a Cartesian equation of a plane, what's the most obvious thing to look for or to use? And the answer is a normal, right? Cartesian equations of planes tell us what the normal is. So if we look for the normal of our first line here, it's going to look something like that. I'll just draw it as a solid red line, something like that, right? And if we look at our normal of our second line, it's going to look something like that. Well, using a little bit of geometry, you can sort of realize that these 2 lines are 90 degrees apart, and these 2 lines are 90 degrees apart. So if that's the case, won't the angle between the normal also be theta, the angle between the planes? And it's true, the angle between the normal is always equal to the angle between the planes. Okay, because it's just shifted by 90 degrees in both ways. The normal is just 90 degrees from the plane, right? So if we know the angle of the, if we know the 2 normals of these vectors, if I call this plane A and I call this plane B, for example, I can find the normal of A is 1, and then there's no y component, so it's going to be 0, and negative 1. And then the normal of angle, or plane B, is going to be 2, 1, negative 1. If I can find the angle between those 2 vectors, that will tell me the angle between the planes. So I'm going to leave that for you to do, because you know how to find the angle between 2 vectors. Hint, hint, use a little bit of dot product. So if you do that math, it should come out that your theta is 30 degrees. So the angle between the normals is 30 degrees, which means the angle between the planes is also 30 degrees. This is also applicable because if we want to know if 2 planes are perpendicular, we should be able to do the same thing, right? And the dot product of those should be 0. The dot product of the normal should be 0. And same thing if 2 planes are parallel, the normal should be parallel, right? Which we can find by using cross product. So we're asked to find the vector and parametric equations of this plane, right? That might seem like a daunting task. How do we even start this? My instinct tells me this equation, the Cartesian form of the equation, is useful for helping us sketch this plane. So if we start with that, if I call this the y, the x, and the z, right? Just like we did on the previous page, I can sketch this plane pretty easily. If I can sketch it, maybe I can find some vectors, right? Because really, essentially what we want for vector form is we want a point on the line, and we want some vectors, and then we can find the parametric equation as well. So if we can find some vectors, we can do it. So hopefully you can see where I'm going with this. First of all, let's find the x, y, and z intercepts. So the x-intercept, I'm going to just sort of go through this pretty quick. The x-intercept is going to be 6. The y-intercept is going to be, if I bring that 6 over to the other side, divide by negative 2, that's going to give me negative 3. And the z-intercept, if I bring that 6 over to the other side and do 6 divided by 5, it's going to be 1.2. Okay, so that's our x, y, and z intercepts. So we can plot that pretty quickly. The x-intercept is 6. I'm just going to do a really rough sketch here. Z is 1.2 and y is negative 3. So just sort of sketching this plane, it's going to look something like that, right? Now, in order to do vector form, we need to be able to have 2 vectors, right? 2 direction vectors. So we can easily find 2 direction vectors now that we know these 3 points. For example, we can find those 2 direction vectors there, right? Because we know what those 2 points are. So if we just find the difference to those 2 points, we can do it. So just to summarize here, I'm going to find my direction vector 1, which I will call A. Yeah, let's just go for it. So A is going to have, I call this down here A. So it's basically the 2 points we have are the x-intercept and the y-intercept. So the x-intercept is going to have values of 6, 6, 0, 0. And actually, let's just write these down. X-intercept. It's going to be 6, 0, 0. The y-intercept is going to be 0, -3, and 0. And the z-intercept is going to be 0, 0, 1.2. Sorry about the messiness down there. I just wanted to squeeze it in. 0, 0, 1.2. So A is the difference between y and x intercepts. So 0 minus 6 is going to be -6. -3 minus 0 is -3, and 0. So there's our direction vector A. And then we can find our direction vector B, which is the difference between the x and the z intercept, right? Which is going to be 0 minus 6 is -6, 0 minus 0 is 0, and 1.2 minus 0 is 1.2. So we have our 2 direction vectors that are on that line. What do we need in order to write the vector equation of the line? Well, we just need those 2 direction vectors along with a point on the line. And we can really choose any of those 3 points as our point on the line. So essentially, our equation is just going to be our point. I'm just going to choose the x-intercept, 6, 0, 0, plus s times our first direction vector, -6, -3, 0, plus, I'm going to run out of space here, plus t, -6, 0, 1.2. Now that we have that, I'm out of space, but you can easily generate the parametric equations for that. This last question, I think you should be able to handle this question, so try it yourself. If you're stuck, I like to draw a quick sketch. I'm just going to sort of randomly put a plane here with 3 points like this, P, Q, and R. Right, so this is 3 points on the plane, and one way to think about doing this question, we need to basically find vectors, direction vectors for this. We already have points, so we can, for example, we can find this direction vector and this direction vector, and that's the one that I'm going to do. So if you want to check your final answer, you can check with PQ and PR as your direction vectors. So pause it here, try to find your equation, and then see if it matches my answer. So there's the answer. Using those 3 points, P, Q, and R, using the vectors P, Q, and PR, we can generate the line. So the line equation is up here, the vector form of the equation, and then breaking that down into the parametric form is there. And then I just said find 2 other points on the line. And we can do that pretty easily by just plugging in random values for s and t. So I think the easiest values to plug in, I plugged in, for this one, I plugged in s is 0 and t is 1, and that generated this point here, and then I plugged in s is 1 and t is 0, and it generated this point here. There you go.